So we discussed this file in the previous class, and we discussed what deployment is, what specs are, and what template is, and what this. Let's go and implement this.
Zishan, can you go over again? Like template is just a template of similar application. Is that what it is?
Template is we are creating a pod here. Let's say if I am creating a Nginx pod, I am using the template. And below that, we are selecting the Nginx container. Let's say we have a template Apache. So under the specs, we will pull the image of Apache, and the template, under the template, we are telling that you will use the label app Nginx or Apache, and you will attach that label to this container, which makes it a pod.
Okay. Okay.
Okay. So I have Minikube available. The real cluster was actually, it is having some issue. I was not able to figure it out. So to continue and to stop wasting time, I'm going with the Minikube. We have all the commands there, or we can do pretty much everything except few changes are there, which I will explain you when we will reach there. So let's say this is our project, and what we will do is, just like we did in Docker Compose -f and the file names. So here we will do kubectl. So kubectl apply -f nginx YAML. So our deployment is created just like that. And let's say I want to see kubectl get pods, and our pods are running. Under the deployment, okay, can I call it notepad? Yes. Under the deployment, nginx.yaml, we set the pod to 1. We all agree that. And let's say, okay, 2 replicas. Let's say if I go, I need 4 replicas, and I can save this file. And now I can go to the terminal again, and I will run this file again. I can load this file, and if I see get pods, now our pods are 4. 2 are running before, and these 2, 0 by 1, 0 by 1, they are creating, and they are running now. So just like that, we can increase the number of pods, or we can decrease the number of pods. We don't need to do anything else. We just tell our deployment that how many replicas we want. Okay. Let's say I have kubectl get deployment. I have one deployment running. And if I say kubectl desci describe deployment nginx deployment, we have nginx deployment. The namespace, we will discuss namespaces later. The namespace is default, label is nginx, and selector is also nginx. We have 4 desired replicas, 4 updated, 4 total, 4 available. So the state is, the desired state was 4 and available is 4. So everything is good. Strategy type, rolling update. What's a rolling update? I told you this is a highly available cluster and a self-healing cluster. Rolling update means, if let's say we have our app running and we have new version available and we want to pull the new container. So what it will do is, it will just not destroy everything and pull the new containers. It's a rolling update. It will start creating new container, and simultaneously it will start deleting the old containers or the pods. I should use the word pod here. So rolling update strategy is 25% max unavailable, which means 25% of the pods will be deleted. The new 25% will be added, and the next 25% will be deleted. So that's how our downtime is 0. So this is the deployment strategy of this cluster. Then we have, this is the strategy. And again, let's talk about the template. The template label is nginx. Container name, we are pulling this nginx image. The port inside the container is 80. And we have not specified any volumes. And One more thing we will find is, yep, first we deployed 2 pods, and then we scale up replica set to 4 from 2. If we go to 2 again, this information will also be added that now going 2 from 4. So this is our deployment. We discussed our deployment, and now we know we have to one more thing, kubectl get pods. So the pods are running, and if I say -o wide, I told you that every pod gets a unique IP address automatically. So all our pods are running, and they are assigned with the IP address, and when new pod is created or recreated, new IP will be assigned. As we can see, we discussed this file yesterday, that now our pod is created, but we need to attach a service with it. So we will be using API version, and the kind is service. Here the kind was deployment. Now we will be creating the kind service. And the metadata, because it is a service, so I called it Nginx service because this service belongs to Nginx. So I can name it anything, but we need to be persistent. Selector, I am selecting the app Nginx, and I am saying protocol will be TCP and expose this port 8080, and the service will listen on some IP and on this port, and on the back end it will talk to our container port, and we already defined the container port here. So let's say go again to the terminal and now do the deployment for our Nginx service. So our Nginx service is there. One more thing, by default, let's first check kubectl get svc, or you can type services. So you have Nginx service available, and service is also assigned, and IP is assigned to the service. And the port, it is listening on port 8080. So when someone will be coming on this IP and this port, it will connect to our Nginx container on port 80. There is no external IP associated with it. And the cluster IP means it is the internal IP, and there is no external IP because we are talking right now about the internal services. When we will be configuring external services, we have to define it. By default, the service is internal. So let's say kubectl describe service, and our service is Nginx service. Okay, the namespace is again default. Selector is, I am selecting the app Nginx. Type is cluster IP. Cluster IP means internal IP. IP family policy is single stack. We are running a single stack here. Dual stack means you can have IPv version 6 and IPv version 4. We are just using IP version 4. This is the IP address. These are the ports. This is the target container port, and these are all the endpoints. So I told you service is a load balancer. And if I say kubectl get pods -o wide, so you can see this IP must be present here, 31. The next one is 32, so we have 32 available here. So next is 33, and we have 33 available here, and plus one more. So the service is automatically load balancing the traffic among all our pods. So this is the example, very simple example of our internal service, but we cannot talk to it externally. So what we should do? I have created, let's go back, and I have created another project. We will configure our MariaDB. Okay, let's go back. I have my MySQL deployment. Yes, I have it. Okay, Notepad. MySQL deployment.yml. So this is our deployment. Again, we are talking about the deployment here. This is MySQL deployment. And the labels are MySQL. I will have one replica available. This is the same standard stuff. Everything is same till here. Now we are making our container MariaDB 10.9.7. The default container port is, we all know that MySQL listens on port 3306. And these are our environment variables. If you remember, or I can go to Docker Hub, that whenever we create a MySQL pod in Docker, when we were doing with Docker Compose, we have to provide these environment variables so that our database is set, and we can use these credentials to log into our database. So kubectl apply -f MySQL deployment. And let's say I need to describe this kubectl describe. You can see anyone working on this cluster, they can see what is the username, what is the password, what is the root password. So our deployment is like anyone working on the cluster can see the credentials we are using. Fine. Let's go and delete this deployment. I can just do delete -f, and our deployment is gone. So we discussed yesterday a few more things. Let's first open the image file so that we know what we are gonna do here. Okay. I have created another deployment. We discussed what config map is. We discussed what secret file is. And we discussed what service is. So let's go here. It is the standard deployment, MySQL container port, and these environment variables till this -name MariaDB user. So before that, we gave the value that username will be admin, the password will be root123. But now what we are going to do is we can create a secret file. So this is our secret file. So kind is secret. Metadata is I am calling the name of this secret as MySQL secret. It is standard type is opaque, and I am defining some variables here, MySQL admin user, and I am defining the username, MySQL admin password. This is the MySQL admin password, and this is the root password. Whatever this root password, it is encoded in base 64. So let's say we want to use this value of MySQL admin user here. So what we will do is we will take value from the secret key reference and the name MySQL secret. This is the name. This name is MySQL secret. So whatever we define here, the name, just like the labels, we call it here. And we will take the key. Key is the the key is the value. Like the key can be MySQL admin user. The key can be MySQL admin password. The root, any one of the value can be the key value. So we are defining the key values here, the variables here. So for MariaDB user admin, I am using the value myadmin user. Same is the case with for MariaDB password, I am taking it from secret key reference. And name is MySQL secret. Again, I am calling this file. And I am taking the value admin password, and the root password, I am taking the value MySQL root password. So these values will come from the secret file. So first of all, we have to, now what should be the sequence of creating the files? First of all, we should create the secret so that these values, when we are deploying our deployment, these values can be taken from the secret file. And when this deployment is done, we can do the MySQL service deployment. Any confusion here? I mean, you should unmute your mic. Otherwise, I don't know.
Could you repeat the sequence once again, please?
Okay. Secret is required in your MySQL deployment, right? So if secret file is not there, these value will not be set. So first of all, because MySQL deployment is dependent on MySQL secret file, so our secret should be deployed first. so that
Okay.
when we are deploying the MySQL deployment, so it can take the values from the secret. And then we can define the service, because the service is talking to a container. So there has to be a container so that service can talk to it. So it is
Okay.
pretty logical sequence.
Got it.
So let's go on the terminal again. And I will go kubectl apply -f MySQL secret. So our secret is there. Secret is there. It is unchanged because I have already applied this before while testing. Then we have MySQL deployment created, and then we have MySQL. The secret is their service. So okay, all the three files are there. Let's say if I do kubectl get all, everything. So we have our service, MySQL service there. We have our Nginx service. It is from the project one. Then we have deployment, and we have everything available. So what should do now? We can say kubectl get pods, and we have our MySQL deployment there. So what I can do is kubectl exec -interactive terminal bin bash. So we are in our container, and if I do my, okay, I am in the Nginx. Oh, come on, exit. I wanted to go in MySQL deployment. Okay, now we are in MySQL deployment. If I do MySQL -u root p, and the password could be, let's enter the password. Okay, we are good with the password root123. So if I do exit from here, I am inside my container. So exit from here, and now on my PC. So if I do kubectl described, and what was our deployment name? MySQL deployment. I hope this was the name inside. So user is set to key MySQL admin user in secret. I cannot view it. So anyone working on the cluster, if it is working on my same domain, I mean, we can have multiple people working on the same cluster, and they do not know my password anymore because they don't have that secret file. So that's how you hide the passwords, and you should use the secret configuration. But if you don't want to do it, so we have both options available. So let's go to see what we want to do else. Okay. If you guys remember, we configure database through phpMyAdmin. So what we should do is we should configure phpMyAdmin also. So now we are gonna deploy phpMyAdmin. And let's say I hope on the right one. So I have tried to create the references, and I can zoom it. MySQL deployment is the same. MySQL service is the same. We are referencing MySQL under the MySQL service. I am just calling the container or the pod MySQL. Everything else, we just did that. The secret file is used here, and we can, okay, config map and phpMyAdmin deployment. So let's say first go to phpMyAdmin deployment. Till here, it is a pretty standard stuff. Excuse me. We have phpMyAdmin app. We will do the labeling, and we know what labeling is, and we can define the template. And we know phpMyAdmin container runs on port 80. And mostly when exposing the port, we do 8080 because mostly port 80 is used for Apache or Nginx. So we expose port 80 for Apache and Nginx, and we expose port 8080 for phpMyAdmin. But inside the container, the port is again 80. Because what is phpMyAdmin? It is actually Apache running inside, and on that Apache we have a web page which has some code available that can interact with the database. So it's sort of a website. So again, it is running on port 80. So if you remember the thing PMA host, what is a PMA host? Just tell me quickly.
It's your host where
The
your
phpMyAdmin will connect.
admin connect to. Yeah.
It will connect to phpMyAdmin. Now we have two
Yes.
options here. We can only define PMA host, and it will connect to our database, and it will ask for username and password. What we can do is, if you want that phpMyAdmin do not ask for password, and it will connect automatically. So we will give a field PMA user. We have defined the host. Okay, host will be MySQL server. So from what user I am gonna connect. So again, I can take, we have the secret reference available, MySQL secret, and we have defined their PMA user. So we can take the value of MySQL admin user from this secret file. And we have again MySQL admin password. So I can connect with MySQL admin password. Or I can connect with, okay, I have to define another user, MySQL root user. And then I can connect to MySQL as a root user. And I can define the MySQL root password here. But I guess I have not used in the secret file. I have to check the actual file. Otherwise, I can define it. It's no big deal. I can just add another variable, MySQL root user, and I will call that root user here. But so far, we are good with the admin user. Now, the config map. We discussed config map. What was it?
It gives us the environment of the pod.
Yes, we are referencing the database. We know that our database or our application has a connection string that connects to the database. So let's say our application says I can define the database connection as MySQL service or my DB service. So what it will do is, my app is running, my application is developed, the container is pushed to the Docker hub, and let's say for some reason we need to change the backend database. So if we have defined MySQL service here in the application connection string, I can go there and I can show you. So if we want to change the backend database, maybe the database before it was MySQL. Now we will have MySQL 2. Maybe we might want to connect to Oracle for some testing. The problem is, then I have to go in our application, change the correct connection string to, let's say, Oracle service. I have to compile that container. I will have to push that to the Docker hub, and I need to pull that again in my deployment. So we should not do that. What the application is there, MySQL service is defined. So MySQL service will do what? It will go to this MySQL service, and you can change the reference MySQL to anything else, MySQL 2, or okay, let's leave it here. Then we have phpMyAdmin service, and we define the service as load balancer. Before, for MySQL, where is MySQL service? Yes, we were defining the service. The spec is selector. Below selector is our app. Here, below selector is our app, and the type is load balancer. We are not defining the type here. We can discuss this file again after deployment. So the type is load balancer. Load balancer means an external IP will be assigned, and we can communicate with our phpMyAdmin services externally. This is the port which I am exposing phpMyAdmin. This is the target port 80, and this is this node port. Actually, I have to define this node port because I have a single node running, and in Minikube, because I'm running Minikube, I have to define the node port, and I have to do a simple command, which we will see in a while, so that the external IP is connected to the external service, because Kubernetes by default do not provide the load balancer anywhere. So if the Kubernetes is running in GCP, Google Cloud, so Google Cloud will have its own load balancer that will assign this IP address. If we are using the AWS load balancer service will assign this IP address. So in Minikube, we have another module which will assign this load balancer IP to the external service. So let's go back and just first do the deployment, and we can come on this screen again. Okay, so we have our deployment. So let's say our MySQL is the same, secret is the same, MySQL service is the same. We have now config map. So just do kubectl apply -f config map. So config map is required in MySQL, or sorry, PHP-MyAdmin deployment. And then we have PHP-MyAdmin service. Now if I do kubectl get pods first, so that I know all the pods are running. Okay, all the pods are running. Kubectl get svc. Now if you can see, the external IP is pending. Why it's pending? Because there is no load balancer running inside this Minikube setup. So I have to use a command.
So Zishan, we don't have to run the service.yaml as, or it's already, you already ran it.
No, I just ran it.
The secret, sorry, secret.
No, because I have not run the MySQL deployment also, because we just did it in our previous example. So I have MySQL deployment there. MySQL service is there, so I don't need to deploy it again until and unless if we are changing something.
No, I meant to say the secret file, like the way you did the config map one, right? So don't we need the secret one as well?
Because we
It's
have
using the
not,
same secret file, I guess.
I am taking the same secret file because it is the same project. Config map,
Okay, so
I
you
have
already
not,
had it. Okay.
I already had it. So I am
Okay,
just
okay.
referencing it.
Okay. Okay.
So what I should do now is, okay, I forgot what I was telling you. Yeah, I was telling you that this IP is pending here, and it will remain pending till we do the command minikube. This is a module by Minikube, so it will not work on production cluster, because there we run kubectl. So we will do Minikube service, 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 and what's the service name? PHP-MyAdmin service. So when I will press enter, it will open a browser for me automatically, which I will share with you. But let's first hit enter. Okay, it just popped the browser. Let's first go to the browser. And on the browser, I am connected to user, to database, to admin user. So I don't have a lot of databases because I have limited permissions. So what I can do is I can connect in the next project, when we will be creating the databases. So we will connect with the root user. So our PHP-MyAdmin is running, and it is running on port 3001, which, let's go to the terminal. And if I hit notepad, and the service name was PHP-MyAdmin service. And I can show you that I have used the port 3001 here. And the same thing is depicted in namespace default, service PHP-MyAdmin, target port is 8080, and I am exposing 192.168.59.105 colon port 3001. Actually, this IP is the Minikube virtual machine IP. And on top, and it is exposing the port 3000 on that machine. We all know that Minikube is running, and if you do not know how to run it, I will explain it by the end of this class. So our external service is running, and we can connect to our database using whatever we have discussed. So now let's go to the image again. And if you do not understand anything, you can ask me now, because then we will be switching to next complicated scenario. I mean, this is not complicated. Everything is so well defined and everything is so well connected. We are taking the config map value from this config. We are taking this. The only change will be here we are saying that secret key reference. Here we are saying config map key reference. Here we will define our config map name. Here we will define our secret name. That's it. Everything else is just like the standard PHP MyAdmin deployment. We are labeling the pod. We are under the service. We are connected to our app PHP MyAdmin. We just added the type load balancer. And when the type is load balancer, let's go to the terminal actually again. So what I should do is kubectl describe describe service, and the service name is PHP MyAdmin.
You spelled service wrong. It's
okay. Describe service. So you can see before the type was cluster IP. Now the type is load balancer, and we have only one endpoint. That is our PHP MyAdmin container or pod. Sorry, I'm using word container again. So the type is load balancer. So let's go back. So I think we are good with this. Can I move forward?
yes.
Good. So let's have our terminal here. And if I go back, I can go to. So in the theory, we discuss our deployment. We are done with our deployment. We discuss replica set. We are good with replica set. We can say we can have multiple replicas. We discussed config map. We discussed secret. Now the problem with the external service is we can listen on IP address and port only. And if we are in a testing environment that we know that, okay, fine, I know the IP address, I know the service port, so we can test it fine. But if we are running up our application publicly, so we cannot go with the IP address and port. We have to go with the standard port 80 or 443, and we have to go with the standard domain name, like any domain name, which can be publicly accessible and which can be publicly resolvable. Means there should be a DNS entry globally somewhere. So considering that, let's say the MySQL deployment is the same, the config map is the same, and I did one more thing. Let me show you what I did. For simplicity, what I was doing, I was creating the deployment separate, and I was creating the service in a separate file. But we can have our deployment. This is our deployment, and if we put 3 dashes here, we can again add our another deployment, or we can define our further configurations. So I am defining with MySQL service. I have copy paste the code of MySQL service in the MySQL deployment. For Nginx, I have done the same thing. So let's go to PHP MyAdmin. So for PHP MyAdmin, I copied the service code here, so that I need to run only 2 files. I should not be running 4 files all the time. I mean, applying configuration for 4 files. So you can have another enter and just 3 dashes, and you can start configuring something else. So let's go back to the terminal. So that's why I have reduced files here. So I have my Nginx deployment. It is the same as before. The secret is Let me again check. I have MySQL secret. No, I have not defined the username in this file also. So let's leave it. So PHP MyAdmin deployment with internal service. What I'm gonna do is before, let's first open PHP MyAdmin deployment. Let's share it again. If you remember, we have defined the type as load balancer. Now I am not doing it. Okay, there is a mistake. The container will listen on port 80 here. So everything is the same, and I am not using the type as load balancer. If I am not using the type as load balancer, then it means it's an internal service. So when I will apply this file, because I am modifying the PHP MyAdmin service, which is already there, the new configuration will be applied. So let's go and see it. Describe. Service, as we see. And the service was PHP my admin dash. So the type is load balancer. So let's say I had kubectl apply -f PHP my admin deployment, whatever the name is. And it has said that the service is configured and deployment is configured. If nothing is changed, it will say nothing is changed. So let's go and describe the service again. Now it is changed to cluster IP. Before it was load balancer. Now it is cluster IP. And if I hit kubectl get pods minus void. So we have our pods running. So we can go get services. And you see the pending thing is gone. We are now using an internal service only. So let's say now we want to configure the ingress. So what ingress does is it takes the request as a domain name and forwards it to the internal service. Let's first open. Let's have, if I have some image available here for this deployment. Okay, yes, I have an image, but I should be inverting it. Anyway, just let's share it. This is the config map. It's the same. This is MySQL secret. This is the same. Our MySQL deployment remains the same. The PHP MyAdmin, I have changed the service to normal service. And this is our ingress. Let's zoom it a bit. So I am using the API version as networking.k8.iov1. I have defined the type ingress. The name is PHP admin ingress. The namespace is default and the specs. So because we are dealing with the domain name here, so we will type under the host phpmyadmin.com. I am defining some website because this is my PHP myadmin page. So I have defined it phpmyadmin.com. It is, we can define custom paths here. And this is the root path. Whatever comes after this will be loaded. And the backend service is PHP myadmin service, which is running on port number 8080. And we know PHP myadmin service is running on port 8080. So we are telling that the backend service will be PHP myadmin service. So we are calling this service. This service is running on, is also running on port 8080, and the target port is the 80. I mean, the container is running on port 80. So what PHP selector will do is it will connect to PHP myadmin, which is running here. And the container port is not 8080. I have defined it 80 here in the configuration. So let's if first check that if I did the right thing. Let's share So it's phpMyAdmin.com, and let me check one more file, and that be phpMyAdmin deployment. 80. Okay, container port is 80, target port it is. Everything is done, perfect. So let's deploy the ingress. New share. And let's do kubectl apply -f. What is the name? phpMyAdmin ingress. So our ingress is now created. And what I can do is I can go to my browser. No, first I have to do one more thing. It is Minikube. Minikube has an add-on. Minikube, it's not, I'm not typing kubectl. I'm typing Minikube here. Add-ons, enable, ingres. So let's wait for it till it is completed. So Minikube gives out of the box add-on for our ingress service, and it is actually deploying an ingress pod. Till here we are clear? So I am taking like every scenario without using any config map, with using config map, with using load balancer, without using load balancer, with communication through internal service, communication through external service. And let's say ingress add-on, it is verifying it. The best thing is you can deploy your Minikube setup. It is very easy and you can practice it all. Then you will get it. You will get the concepts. Write your own YAML files. Configure Apache, MySQL, Nginx, whatever app you want to do. And when you will implement it, then you will know the concepts. Okay, our ingress is enabled. So what I can do is kubectl describe. What was the name? What was the name? It was phpMyAdmin ingress. Or what I can say is describe or get. So I have my phpMyAdmin ingress running on phpMyAdmin.com is running on 192.168.59.105. Again, I'm telling you, this is the IP which is assigned to my Minikube virtual machine. So I have entry of phpMyAdmin.com in my etc host file. And let's say I can go to the browser. And if before it was port 3000, now I can go on phpMyAdmin.com. Okay, it is using the username and password. Let me check if it is root and root 123. Okay, it is connected. Why it has asked the username password? Let's go to the terminal again and see that PHP MyNginx deployment with internal service. So we have configured this service. We have deployed it again. And what I did is I am not taking the username and password in the file. I am not hard coding it. So if you're not hard coding it, it will prompt for username password. Before that, I have in previous configuration file, I have defined pma_user and pma_password. Because I'm not defined it, so it is asking for username password, and we know we set the username password root and root 123. Got it? So now we can create our databases, anything from our You can create database anything example. Done.